Welcome back. In the previous chapter, we started with rates of returns. In this video, we're going to work a little more on compounding. I've already snuck in some examples of compounding into the previous set of slides. Alas, we're going to do a lot more compounding in the rest of this course, so let's practice this a little bit more to firm it up. Compounding. When you invest money over multiple periods, you're earning interest not only on your principal investment, but you're also earning interest on the interest itself. Now, sometimes it's easier to work with daily rates of returns. Other times it's easier to work with annual rates of return. You need to know how to convert seamlessly between them. For example, if the one-year interest rate is 20% this year, how much return will a $500 investment today yield in 1 year?
Please pause this video now, answer the question on a piece of paper, and then continue.
In year one, the $500 becomes $600. Now, if in the following year the interest rate will be 50%, how much return will you have at the end of 2 years?
Please pause this video now, answer the question on a piece of paper, and then continue.
Well, you take the $600, you multiply it by 1 plus 50%, and you have $900. What is the formula for the total 2-year holding rate of return, given the two consecutive rates of returns of 20% and 50%?
Please pause this video now, answer the question on a piece of paper, and then continue.
It is not 50% plus 20%, which would be 70%. Instead, it's a formula that has 1 plus r's multiplied. So it's 1 plus 20% times 1 plus 50%, which equals to 1 plus 80%. The difference between 70% and 80% is the rate of return on the rate of return. The general compounding formula is this 1 plus r formula. Hello, wake up. This was not the correct formula. Pay attention. You have to catch my errors. Don't trust anyone over 30. Certainly don't trust your professors. I'm notorious for errors, but no matter what I do, you should be skeptical. The correct general compounding formula is 1 plus r equals all the others 1 plus r multiplied. If the interest rate remains constant, then we can just use 1 plus r, the same one, to the power of t. And here is a graph where you just have 20%, and it's not just a linear function, but it goes up. Now, many graphs and websites display such returns over time on a logarithmic y-scale, because otherwise what you get to see is in the beginning not very much, and even though it's the same amount, even though it's 20%, and in the end it rockets up. So, not much choice. The best way is to put it on a log scale, and that actually will make it a line. Now, the difference between adding returns, r01 plus r12, and compounding returns, 1 plus r01 times 1 plus r12 minus 1, is the term r01 times r12. This is called the cross term. Multiplicative terms entailing multiple r's are also called the cross terms. And when you have many different periods, there will be a ton of these cross terms. If the 1-month return is 1%, then what is the 1-year rate?
Please pause this video now, answer the question on a piece of paper, and then continue.
Well, there are 12 months in a year. After 1 month, you have 1.01. After 2 months, you have 1.01 times 1.01, etc., etc., etc. So it turns out it comes to 12 0.68%. For every $100 invested, you will have $112.68, not $112. If the daily rate of return is 0.02%, as it may be in a savings account, what is the annual rate of return?
Please pause this video now. Answer the question on a piece of paper and then continue.
That turns out to be 7.58%. It's a little bit more than the multiplicative version, which would have been 7.31%, but it's very close. Is compounding more like adding or more like averaging rates?
Please pause this video now. Answer the question on a piece of paper and then continue.
It's more like adding. A 10% rate of return times 2 is 20%. Compounding it is 21%. So it's very, very similar. Averaging, of course, would be back to about 10%. If both R and T are small, then the approximation will be okay. That is, instead of doing the formal compounding to the power of T, you can just take T times the interest rate, add it to 1, or then subtract 1 again, and you'll get a very similar number. The cross terms are small when dealing with few periods, small interest rates. Here are 2 examples of that. So 0.02% per day at 2 days. The difference is 0.0004. The cross term is 0.000. Who cares? Adding up instead of compounding becomes a worse approximation as time and interest rates increase. For example, 100 years at 10%, you would end up with $13,781. That's very different from not compounding, in which case you only end up with $10. For risky projects, cross products may or may not be worth worrying about. For example, if the uncertainty is about plus or minus $100,000, then worrying about $3 in cross terms seems outright silly. Easy? Sure. Done with compounding? Almost. What could go wrong? Well, I forgot to mention a small minefield. What you are being told are interest rates often aren't. They're interest quotes. They are standardized ways to describe interest rates, even though they aren't. These interest quotes are long-standing conventions. Some may have even come about intentionally to deceive the ignorant. Most are just historical circumstance. It's particularly deceptive when they look similar to what a real interest rate could look like, and many are. When you're not sure, don't be embarrassed to ask for a simple example calculated for you. So let's start. A bank quotes you an 8% interest per year for its savings account. If you invest $1 million in this bank for 1 year, how much will you end up with?
Please pause this video now. Answer the question on a piece of paper and then continue.
It's not 8%. If you answered $80,000, wrong. 8% is not a true interest rate. It's an interest quote. You are supposed to already know this. So what banks really do is they typically mean something compounded daily times 365, and sometimes just 360. Thus, the bank, when they quote you 8%, mean they pay you 8% divided by 365 per day, and for some banks divided by 360. Over 1 year, this compounds to 8.33%. So what you will end up having is $1 million, $83,333. So interest quotes versus interest rates. Banks typically quote interest rates by multiplying daily compounding interest rates by a number between 360 and 365. Many lenders with monthly repayments will use monthly quotes multiplied by 12. By the way, even Julius Caesar knew that 360 was wrong, and he invented the calendar. No, he didn't invent the calendar, the Mesopotamians did. Shit. Again. By the way, even Julius Caesar knew that 360 was wrong. That's not a year. Although calculated daily, the banks still credit interest payments only monthly, so you will not see a new statement every day on this. Some banks also add a little bit of extra information for clarity, such as interest rate 8% compounded daily, effective annual yield 8.33%. Benevolent banks, aren't they? Great for customers, right?
Please pause this video now, answer the question on a piece of paper, and then continue.
Not really. See, banks use the same convention in calculating overdraft and some lending interest rates. So it will make both loans and deposit just look different from what it is, and customers sometimes pay more and sometimes get less. Now, here's another quote. A US Treasury bill quotes an interest of 95. Huh? What the heck? Well, this is because at auction the Fed sells Treasury bills that pay $10,000 in, say, 180 days. If the discount quote is 10%, which is absolutely not an interest rate, you can purchase one for $9,500. Many decades ago, this was all published in newspapers, and newspaper space was precious. So to save space, this was quoted as 95, and this convention stuck. So it's still being used today. Don't bother with the details. You don't need to. I don't remember these things either. You can actually translate this interest quote into an interest rate. Now, there's one reason why I do like this convention, because when I read 95, there is no risk of confusion. I know I'm dealing with a quote rather than with a rate. So, quote convention recap. Banks quote many interest rates compounded by 360 unless otherwise specified. Lenders quote many interest rates compounded 12 unless otherwise specified. That still often ignores upfront points, payments, fees, or other things. True interest rates are sometimes called effective yields, sometimes in other contexts also APRs, annual percentage rate. Something even more important to remember, it's not your instructor's fault. Don't shoot the messenger. I hate needless confusion even more than you do, but these are standard conventions. Now, let's do a slight turn. First, I want to cover the opposite of compounding, which is uncompounding. It may even save you some money next time you go into escrow on a house. Second, I want to calculate how long it takes to earn a certain rate of return, like how long does it take to double your money? It'll be quite quick and painless. Well, at least for me. I don't know about you. So here's exponentiation algebra. Here's a reminder, you did this in high school. X to the power of a equals b. So you want to move this over to the other side. X equals b to the power of 1 divided by a. And if you want to solve for an x that's at the exponent, then you have to use a double log. The b is in the numerator and the a is in the denominator. So here's a question. A project for $200 promises to return a true 8% per year, but allows fair withdrawals at any time. How much money would you have after 2 months?
Please pause this video now, answer the question on a piece of paper, and then continue.
First, the monthly rate of return is 1 plus 8% to the power of 1/12. That turns out to be about 1.006434. Then compound this twice to obtain 1.29%. Or if you want to make it easier, just calculate 1.08 to the power of 112 times 2, minus 1. Such interest rate calculations are often needed, for example, when you want to prepay your mortgage. Let's work a realistic Los Angeles example that seems almost unreal. In February 2025, right after the big fires, the median listing price in Pacific Palisades was $4.7 million. Homebuyers typically finance 80% of their mortgage. For the median priced house, this would be having to finance $3.76 million. Now, the APR for a 30-year fixed rate jumbo mortgage appropriately compounded was 7.15% per year. Now, what is the daily interest rate, i.e., the capital cost of carrying this mortgage for 1 day?
Please pause this video now, answer the question on a piece of paper, and then continue.
It's 1.0715 to the power of 1 divided by 365.25. That's a very small number, 0.0001890, blah, blah, blah. But of course, we're going to multiply it by a big number. So what is the difference between paying off the mortgage 1 day earlier versus 1 day later?
Please pause this video now, answer the question on a piece of paper, and then continue.
Well, you have to multiply that interest rate by $3.76 million, which is the mortgage that you're about to take. So that's only $711. Yeah, small interest rate, but enough to pay for a Michelin star restaurant dinner tonight. Banks are notorious in wanting to close mortgages over the weekend, in which case they get to retain the full interest on the money in transit. There's no reason today why that has to be the case anymore, but it's money for them, so they've left it this way. I sometimes wonder whether these escrow agencies are complicit and are aware that this just makes more money for the bank. So, if I were you, I would agree only to closing on a weekday to minimize transit time. Like you want to close on a Wednesday. If you're doubling your money every 12 years, what is your rate of return per year?
Please pause this video now, answer the question on a piece of paper, and then continue.
Well, now we have to use the exponentiation algebra that we did before. And if you solve this appropriately, you bring the 1 over 12 to the other side. X is going to be about 5.9%. If projects return 8% per year, how long will it take for you to double your money?
Please pause this video now, answer the question on a piece of paper, and then continue.
Now you have to use the logarithm stuff that we had in the slide just earlier. T is going to be 9 years. In the old days, before calculators, students were taught silly but quicker rules on some of these calculations. It's still on some exams, but really in today's times, this is all nonsense. Just use the logarithmic formula. Now, you have $100. You invest half in each of 2 firms. Firm 1 makes 10% this month. Firm 2 makes 20% this month. How much did your portfolio make in total? And let me just remind you of the compounding, just so you don't have to do it. 1.2 times 1.1 is 1.31.
Please pause this video now, answer the question on a piece of paper, and then continue.
Time out. It's not 31%. This is not the 1 plus formula. Don't lose the forest in the trees. Usually averaging is at the same point in time in a cross section. Compounding is if you have some investment asset that you buy and hold over time. In this particular case, you have to take the average. So depending on what your investment weight would have been, here 50-50, your average rate of return would have been 15%. That's it for this video and for interest rate compounding. Yes, this material is fundamental and super important, but even I have to admit that it's not a whole lot of fun. It's tedious and boring. Exciting? Nah. Well, not unless you're seriously autistic, though many of us finance faculty members are exactly that. Me in particular. In the next video, we'll start on present values. It's the basis of most corporate decision making. See you soon. Bis bald.
The population of Ireland's capital is growing exponentially.
That can't be true.
But it is. Every year it's doubling.
Wow, in Libya, it's tripling.
Ooh.